Hey everyone, and welcome to S.E.T for You, the channel that's all about STEM ambassadors, engineering, and tutoring. Here on S.E.T for You, I'll break down exam questions step by step, explore techniques to improve your problem-solving skills, and even sprinkle in a bit of STEM inspiration along the way. Today, we'll be diving into circle theorems, as these are some of the most important concepts in geometry and very frequently pops up in exams year after year. In this video, I'll walk you through a set of circle theorem questions step by step, providing clear work solutions and tips to help you tackle them with confidence. So grab a pen, some paper, and let's get started. So in the first question, it says the diagram shows a circle center O, and part A tells us to work out the size of angle X. So one of the rules in circle theorem states that the angle at the center is twice the angle at the circumference. Therefore, this angle X is simply double the angle at the circumference, which is 75 degrees. So X equals 75 degrees times 2, and that gives us a value of 150 degrees. So the size of angle X is 150 degrees. In the next part of this question, we are told to work out the size of angle Y. So before I go ahead and do that, I'm going to draw an arc around the center O, because the angle in a circle is 360 degrees, and given that angle X is 150 degrees, this angle can simply be obtained by subtracting 150 from 360. So we do 360 minus 150 degrees, and that gives us 210 degrees. So we know that this angle here is simply 210. We can also see that there is a quadrilateral in our circle, as I've highlighted using my marker, and the sum of the angles in the quadrilateral is 360 degrees. So that means angle Y plus 75 plus 210 plus 18 equals 360. So I'm going to go ahead and write that down. So Y plus 18 plus 75 equals 360. If we simplify the left-hand side of this equation, Y plus 303 equals 360. Therefore, Y equals 360 minus 303, and that gives us a value of 57. So the size of angle Y is 57 degrees. The second question tells us that A, B, C, D, and E are points on the circle, and that AC is parallel to ED. Part A tells us to write down the size of angle X. So before I go ahead and do that, when we take a closer look at this question, we can see a bow tie is formed by connecting A, B, D, C, and A. One of the rules in circle theorem states that the angles in the same segments are equal. That means angle X is simply 70 degrees. The second part of this question tells us to work out the size of angle Y. So you would remember from this question that we were told that AC and DE are parallel. So if I just draw on the lines AC and ED or DE, whichever one you want to call it, when I connect the point AD, a Z shape is formed. Whenever you see a Z shape, always remember alternate angles, because alternate angles are equal. That means that angle ADE is also 34 degrees. So I'm going to go ahead and write that down as angle ADE equals 34 degrees. And in brackets, I'll just state alternate angles. So at least an examiner understands how I obtained that value. In our triangle ADEA, we can see that in order to work out the angle Y, we're also going to need to know this angle AED. If we take a closer look at our diagram, a cyclic quadrilateral is formed by connecting the points A, C, D, E, and A, and opposite angles in a cyclic quadrilateral add up to 180 degrees. Therefore, angle 70 and its direct opposite angle, angle AED, gives you a value of 180 degrees. So to work out the size of angle ADE, I can simply subtract 70 degrees from 180 degrees. Therefore, angle AED equals 180 degrees minus 70 degrees, and that gives us 110 degrees. So this angle here is simply 110 degrees. Therefore, to work out the size of angle Y, we know that the sum of the angles in a triangle is 180 degrees. So I can simply add these values together and set that equal to 180 and rearrange and solve for Y. So Y plus 110 plus 34, you might want to put the degrees symbol there as well, equals 180 degrees. So Y is simply 180 degrees minus 110 degrees minus 34 degrees. And if I put that into my calculator really quickly. That gives me a value of 36 degrees. So the sides of angle Y is 36 degrees. In this question, we are told that A, C, and D are points on the circle with a center O, and that BA and BC are tangents to the circle. Work out the size of the angle Y. So the keyword tangents in this question reminds us of two circle theorems. One of them being that the tangents from the same point to a circle are equal in length. That means BA and BC are both equal in length because they are tangents to the circle from the same point B. So I'm going to go ahead and label them as being the same, right? They're equal. Another circle theorem rule states that the radius will always meet a tangent to the circle at 90 degrees. That means that this angle here is going to be 90, and this angle here is also 90 degrees. So to work out the size of angle Y, I'm going to need this angle. Now, what you can probably note from this question is that because the length OB joins this length OA and this length OC, and BA, BC are the same, and OA and OC are the same because they're radius to the circle, then these triangles are identical, which means this angle here and this angle here are both equal. The angle at the center is twice the angle at the circumference. So that means that this angle here, angle AOC, is double angle ADC, 47 degrees. However, given that these two angles are equal, we can simply state that this angle is 47 and this angle here is 47. All right, so 47 degrees and 47 degrees. Therefore, to work out the size of angle Y, I can simply add 90 and 47 and Y and set that equal to 180 degrees. The angles in a full triangle adds up to 180. So Y equals 180 degrees minus 90 degrees minus 47 degrees, and that gives us 43 degrees. In this question, we are told that PAQ and PB are tangents to the circle, AC equals BC. Work out the size of angle X. You must show your working, which may be on the diagram. So if you do not show your working for this question, you will not be awarded the full marks. Really important to note. So if we go back to the question, given that AC equals BC, triangle ABC is simply an isosceles triangle. An isosceles triangle, for those of you that do not know, is a triangle with two equal lengths and two equal angles. So I'm going to go ahead and write that down. Triangle ABC is an isosceles triangle. Therefore, we can state that angle ABC and angle BAC are the same. So angle ABC equals angle BAC. One of the rules in circle theorem states that the angle between the tangent and the side of the triangle is equal to the opposite interior angle. That means that if we look at our tangent here and the side of the triangle, the angle between those two lengths, right, angle 52, angle CAQ, is simply equal to the opposite interior angle, angle ABC. So we can say angle ABC equals 52 degrees, all right, 52 degrees, and in brackets, I'll just write alternate segment theorem. So alternate segment theorem. Therefore, angle BAC equals 52 degrees. So I'm going to label this as 52 degrees and this as 52 degrees. The angles on a straight line add up to 180 degrees. So to work out angle PAQ, I can simply add 52 to itself and subtract that value from 180 degrees. Angle PAQ equals 180 degrees minus 52 minus 52. 52 times 2 is simply 104. 180 minus 104 is 76 degrees. You can use your calculator to help you work that out, but make sure that your method, your working, is clear for an examiner to see. If we go back to the first part of this question, we were told that PAQ and PB are tangents to the circle. So remember from circle theorems that the tangents from the same point to a circle are equal in length. That means that PB and PA are equal in length because they're tangents to the circle, but tangents to the circle from the same point, P. That means that this length is also the same as this length, okay? So we have another isosceles triangle, and so that means that this angle here, angle PBA, is also 76 degrees. So angle PBA equals 76 degrees. In my brackets, I will just write isosceles triangle, Okay, it's clear, an examiner will know what you mean by that. And so to work out the size of angle X, remember we have a full triangle. You can add these two angles together and subtract that from 180 degrees. So angle X equals 180 degrees minus 76 degrees minus 76 degrees, 76 times 2, and you subtract that answer from 180, that gives you a value of 28 degrees. So the size of angle X is simply 28 degrees. So in this question, we are told that A, B, C, and D are points on the circle center O, that X plus Y plus Z equals 290 degrees. Work out the values of X, Y, and Z. So before I go ahead and do that, I want us to just examine this shape that we've got here. So within our circle, we have a cyclic quadrilateral. This is a four-sided shape with every corner touching the circumference of the circle. So if I point out here, we can see that A, B, C, D, and A form our cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add up to 180 degrees. That means that angle X plus angle Z equals 180 degrees. So I'm going to go ahead and write that down. X plus Z equals 180 degrees. If we use the equation that was given to us in this question, X plus Y plus Z equals 290 degrees, we can substitute this equation into the equation above. But what I will do is rewrite the equation above as X plus Z plus Y equals 290 degrees. So X plus Z is 180 degrees plus Y equals 290 degrees. I can then rearrange to make Y the subject, and so Y is 290 degrees minus 180 degrees, and that gives us 110 degrees. So the value of Y is simply 110 degrees. Going back to the question that we see here, the angle at the center is twice the angle at the circumference. In other words, to work out the size of angle X, I can simply half the value of angle Y. X equals Y over 2, so X is just 110 over 2, which is 55 degrees. To obtain the value of angle Z, I can substitute X and Y into our given equation and rearrange to make Z the subject. So we know X, which is 55, plus Y, which is 110, plus Z equals 290. So Z equals 290 minus 110 minus 55. And if you put all of that into your calculator, it gives you a value of 125 degrees. So we know the value of angle X is just going to be 55 degrees and angle Z is going to be 125 degrees. In the final question, we are told that A, B, C, and D are points on the circumference of a circle, center O, AC is a diameter, angle DAC equals 42 degrees. We'll write down the value of X. So before I go ahead and do that, let's make a note of the number of marks for this question. It is simply 1 mark. So if we look at our diagram, we can form another bow tie. All right, so we looked at a question like this earlier in this episode, and we can see that a bow tie is formed here. So remember that the angles in the same segment are equal. Therefore, angle X is simply 42 degrees. All right, so I'm going to go ahead and write that down as 42 degrees. In the final part of this question, we are told to work out the value of Y. I want us to note something here. Given that AC is a diameter, that splits this circle into 2 semicircles, and the angle inscribed in the semicircle is always a right angle. Therefore, angle ADC is 90 degrees. The sum of the angles in a full triangle is 180 degrees. So when I add angle 42, angle 90, and angle Y, that equals 180 degrees. So Y plus 90 plus 42 equals 180. Therefore, Y equals 180 minus 90 minus 42. And so Y equals 48 degrees. So the value of angle Y is simply 48 degrees. Thank you so much for watching today's video. I hope this walkthrough of circle theorems has made the topic a lot clearer and boosted your confidence for your exams. If you found this video helpful, don't forget to give it a thumbs up, as it really helps support the channel and lets me know you're enjoying the content. And if you're new here, make sure to subscribe to S.E.T for you for more step-by-step math solutions, engineering insights, and STEM inspiration. Also, let me know in the comments if you have any specific questions or topics you'd like me to cover in future videos. I'd love to hear from each and every one of you. Until next time, keep practicing, stay curious, and I'll see you in the next video.